The chance of this trajectory is less than 0.2% to be aligned with the orbit of the Earth around the Sun, less than 1 part in 20,000 to arrive so close to the other planets. And one wonders, could it be a design trajectory?
The solar system just got a surprise guest, and it's huge. Say hello to 3I/ATLAS, the third confirmed interstellar object ever spotted. And this one's a monster. Its orbital eccentricity is way past 1, meaning it's just passing through. No round trips, no returns. Once it slices through our system, it's gone for good. Captured by the Vera C. Rubin Observatory, this beast measures around 7 miles wide, completely outclassing previous cosmic visitors like Borisov, which was just 0.6 miles wide, and Oumuamua, barely 0.2. But size isn't the only shocker. Astronomers peeped into its makeup using the NASA Infrared Telescope Facility and Gemini South, and what they found is wild. This thing is packed with water ice and carbon-rich organic molecules, all mixed with silicates. And get this.
Because it has anomalies. It moves on a trajectory that is very unusual.
The water is chemically pristine. It's missing the heavier isotopes you'd usually find in comets that formed inside our solar system. Translation: this ice might have formed 7 billion years ago, before Earth was even a concept. That makes 3I/ATLAS a frozen relic from a completely different star system, a snapshot from an alien planetary nursery. Scientists are calling it a comet, but with its eerie glow and alien origin, some folks still aren't ruling out the wild theory that it's something more. And it's not just floating around. This thing's blazing toward the sun at a jaw-dropping 130,000 miles per hour, tearing through the solar system on a steep retrograde path. Astronomers are already counting down to some key cosmic events. October 3rd, 2025, Mars flyby. Just after sunrise over Valles Marineris, it'll pass within 18 million miles of Mars. Probes like MAVEN and Tianwen-1 are expected to catch the comet's dusty coma glowing pink in the Martian dawn sky.
Change the arrival time of this object, and only in 1 in 20,000 cases you end up with such a close proximity to the planets, because they orbit around the sun, and the chance of being so close to them is very.
October 29th, 2025, solar swing. 4 weeks later, it'll slingshot behind the sun, getting as close as 1.36 astronomical units, about 130 million miles from the sun's surface. At this point in its journey, 3I/ATLAS hits its top speed, a mind-blowing 152,000 miles per hour. As it whips behind the sun, Earth-based telescopes lose track of it, blinded by the intense solar glare. But don't worry, eyes in space aren't blinking. Probes stationed on Mars and at the L1 point will stay locked in, watching as jets of vapor burst from its sun-warmed crust like cosmic geysers. December 19th, 2025, Earth check-in. The comet swings past Earth at a safe distance of 170 million miles. That's way too far for us to see it with the naked eye, but close enough for the James Webb Telescope and Rubin Observatory to scan its glowing tail for deep isotopic secrets. What they find could reshape everything we think we know about planetary birth zones far beyond our solar system. March 16th, 2026, Jupiter encounter, the final planetary stop. Jupiter. 3I/ATLAS will pass just 33 million miles above the gas giant's swirling clouds. And here's the twist. If NASA signs off on a quick maneuver, the Juno spacecraft could swoop in and grab a direct sample from its dust stream. That would give us the closest look ever at raw material from outside our solar family. But once the flyby is done, this beast is out, curving back into deep space, leaving only terabytes of data and a wave of controversy behind. Because here's where it starts to get weird. Again, some scientists are now floating a theory that sounds straight out of sci-fi. What if 3I/ATLAS isn't just a comet, What if it's camouflaged alien tech? Yep, Harvard astrophysicist Avi Loeb is back in the mix. He's the same guy who suggested Oumuamua might have been an alien spacecraft. And now, he's co-authored a bold new paper titled, "Is the Interstellar Object 3I/ATLAS Alien Technology?" In it, he points out how the comet's huge size could easily hide high-tech instruments. And he brings up the dark forest hypothesis, the eerie idea that advanced civilizations are out there, quietly hiding from predators in a cosmic jungle. Loeb's theory gets even more wild. He suggests that 3I/ATLAS might actually be a disguised alien probe, silently mapping or even eavesdropping on our solar system.
From images, we also saw that this object is active, which means that around the nucleus there is some coma, which is an indication that this object is in fact a comet.
He points to its unusually high inbound speed and steep retrograde orbit, saying those could be signs of engineering, not just natural drift. And check this, the comet's path? It swings suspiciously close to Venus, Mars, and Jupiter, as if it's intentionally cruising past key planets. Loeb argues this idea isn't far-fetched at all. After all, we've already launched our own interstellar messengers. Voyagers 1 and 2 have officially exited the solar system, and Pioneers 10 and 11 aren't far behind. So why wouldn't another civilization do the same? Maybe millions of years before us. And here's where things get creepy. 3I/ATLAS will hit perihelion, its closest point to the Sun, behind the Sun, out of Earth's direct line of sight. That would make it a perfect time to deploy, well, anything, without Earth's telescopes catching it. Devices, probes, we don't know, but the timing is suspicious. Loeb even estimates that 3I/ATLAS entered our solar system about 8,000 years ago, right around the time humans started writing history down. Coincidence? He doesn't say, but that detail alone is making a lot of people raise their eyebrows. Meanwhile, his team is noticing something else strange. This comet doesn't act like a typical comet at all. Spectral scans haven't picked up key gases like cyanogen or diatomic carbon, stuff that usually floats around in a comet's glowing coma. So what gives? So the big question hangs heavy. Is 3I/ATLAS really just space ice and dust? Or is it something else entirely? Most scientists still say no to the alien hardware theory. Since it was first spotted, astronomers have stacked up data, and nearly all signs still point to a natural comet. But not everyone is convinced. The latest images and spectrographs of 3I/ATLAS show exactly what you'd expect from a comet: dust jets and a soft, glowing coma flaring out as sunlight hits its icy core. But what about those missing chemical signatures? The gases like cyanogen and bicarbon, which usually light up as a comet gets closer to the sun? Right now, it's simply too early. 3I/ATLAS is still chilling in the deep freeze of the outer solar system. Most comets don't start showing those flashy gases until they dive closer toward the sun's heat. So if Atlas is truly just a frozen traveler, we should start seeing those telltale emissions real soon. And that already makes it different from Oumuamua, which never released anything. No jets, no gas, just silence. In fact, 3I/ATLAS is acting a lot more like Borisov, another interstellar comet that behaved exactly how a normal comet should. But that leads to one major question that's still bugging scientists. If Atlas and Borisov play by the rules, why didn't Oumuamua? How did it just slip past us, completely quiet, until it was already heading out the other side of the solar system? That mystery still hits hard, and now with Atlas in the mix, it makes Oumuamua look even stranger. October 19th, 2017, the night it all started. A telescope called Pan-STARRS. One scans the sky from Hawaii. At 1:22 a.m., a thin streak darts across the frame, moving way too fast to be an ordinary space rock. Hours later, astronomer Robert Warwick spots it at the University of Hawaii's data center. He checks the stats and realizes something's off. This object is racing in at 26 kilometers per second, and its orbital eccentricity is 1.20. That means it's not coming back. Ever. Within 24 hours, it gets its first name, C2017U1, assuming it's a weird comet. But that idea doesn't last long. It shows no cometary tail. So the C is dropped and it's renamed A/2017U1 for asteroid. Even that doesn't fit. The thing just doesn't behave like anything we've seen before. So the International Astronomical Union creates a brand new category, I for interstellar. And that's how Oumuamua, meaning scout in Hawaiian, became the first official visitor from another star. But astronomers had just 40 days to figure it out before it disappeared into the dark, too faint to track any longer. Oumuamua came flying in at a scorching 26 kilometers per second, straight out of the same region of the sky as Vega, that bright star in the Lyra constellation. Coincidentally, that's the exact patch of sky our own solar system is drifting toward. Wild, right? As it zipped past the sun, it didn't just cruise by. It dove deep, swinging closer than Mercury's orbit, just 38 million kilometers from the solar furnace, then curved sharply and shot back out, untouched by any gravitational assists. It's now fading toward Pegasus, never to return. But here's the problem. Tracking that journey backwards is nearly impossible. Space isn't still. After tens or even hundreds of millions of years, the object's original path has been blurred by gravity nudges from passing stars and the pull of galactic tides. Maybe, long ago, it was tossed from some faraway system by a giant planet gone rogue, and it just drifted, until fate brought it into our backyard in 2017. Or did it? Telescopes around the globe noticed something else. Every 7.3 hours, Oumuamua's brightness surged nearly tenfold, then dropped sharply. That kind of extreme flashing suggests it's either super elongated like a cigar or extremely flat, like a saucer tumbling end over end. But here's the kicker. No telescope ever captured a clear shape. To this day, both versions are still on the table. And then came the real shocker. As it passed one astronomical unit from the Sun, the European Space Agency noticed something off. Oumuamua had suddenly sped up. The change was tiny, just 5 millionths of a meter per second squared, but it was real and unexplained. Now, normally, that kind of acceleration would mean it's venting gas like a comet, classic outgassing behavior. But here's the twist. No dust, no vapor, nothing was seen. Every telescope reported a clean trail, totally spotless. Even stranger, the solar radiation at that distance couldn't have caused that kind of push unless the object had an insanely high surface area to mass ratio. Basically, like something paper thin, maybe a wafer, or a giant reflective sheet. You starting to see why some folks still think this thing wasn't just a rock? Here's the part that really twisted scientists' brains. Nothing in nature can explain an object that's hundreds of meters long, yet thinner than a sheet of paper. So what exactly were we looking at? To find out, NASA pointed the Spitzer Space Telescope at Oumuamua, locking its infrared vision on it for 30 straight hours. Spitzer is built to pick up warm dust from regular comets even from 2 astronomical units away. But with Oumuamua, nothing. Not a single thermal trace. Just silence. But it gets even weirder. What Spitzer did detect shocked everyone. It turns out Oumuamua's surface reflects light 10 times more than the dark, carbon-heavy crust of typical comets. That raised a major question. Was this thing metallic? Then came the bombshell. In late 2018, Harvard astrophysicist Avi Loeb and his team dropped a paper in the astrophysical journal Letters. Since no known natural process could shape something like this, they made a bold call. What if it wasn't natural at all? Loeb suggested that Oumuamua might be an artificial light sail, a piece of alien spacecraft, or a derelict probe from another star system. Basically, alien tech just cruising through space. That theory made headlines everywhere. Some praised it as brave science. Others called it pure hype. But not everyone was sold on the alien idea. Two scientists, Daryl Seligman and Jennifer Bergner, stepped up with a wild but natural explanation. They pointed out that when water ice sits in deep space, just a few degrees above absolute zero, cosmic rays can start breaking it down. Over millions of years, those rays knock loose hydrogen molecules, which get trapped in tiny pockets like microscopic gas bombs. They proposed that as the object gets closer to the sun and warms up, even just a bit, to around 40 Kelvin, that trapped hydrogen begins to leak out, forming invisible jets. These jets could gently push the object without producing any visible dust, heat, or vapor, so no trace for our infrared sensors to catch. They dubbed these sneaky travelers dark comets. And it's a theory that actually makes sense, explaining both the mystery acceleration and the clean trail no aliens needed. Since that first bold theory, astronomers have discovered a whole new class of mysterious objects in our solar system, and they all match the profile of dark comets. These bodies show clear signs of jet-like motion, but without any visible dust or gas. That means they're likely being pushed by invisible forces, possibly from hidden volatile material deep within their icy cores. What started as a wild guess is now a recognized category, but Avi Loeb still isn't buying it. In multiple essays and scientific follow-ups, he's stayed critical of the hydrogen outgassing model, saying it miscalculates how fast the surface would cool once the hydrogen escapes. Plus, he argues that even if the theory were right, we should have seen some detectable effects. But with Oumuamua, we saw nothing. Loeb stands by his theory, a radiation-driven light sail crafted by someone else. So how do we settle this once and for all? Enter Project Lyra, an ambitious mission proposed by the Interstellar Probe Working Group. Their plan? Launch a tiny high-speed probe in 2028 aboard a Falcon Heavy or Starship. Slingshot it past Jupiter for a gravity boost, then dive it close to the Sun for an Oberth maneuver, using solar gravity as a turbo boost to hit speeds of 20 to 25 astronomical units per year. If it works, this craft could catch up to Oumuamua, but not until the 2050s, when the object will be over 200 astronomical units away and dimmer than magnitude 35. That's crazy faint. To pull this off, we'd need to build heat shields tougher than anything we've ever launched, and propulsion systems that push way beyond current limits. It's a long shot, in every sense of the word. But maybe there's a better way. Instead of chasing a ghost through the dark, many scientists now say, let's ambush the next one. And guess what? We might already have. While Oumuamua broke every rule, no tail, no gas, no heat signature, 3I/ATLAS is acting much more familiar. And that is exactly why it matters so much. By comparing these two cosmic outsiders, one quiet and strange, the other active and comet-like, astronomers may finally crack the code on what's truly alien and what's just rare. If you've made it this far, you're one of the real ones. Don't forget to like, subscribe, drop a comment, and share this video, especially with anyone who's into space mysteries, aliens, or the secrets flying through our skies.